Hello everyone, I'm Jeremy Bloom. I've been exploring what I can do with huggingFace for AI ML and for LLMs, and I thought I'd put together this video to show friends, colleagues, and anyone else interested in what I've been up to and what you can do. So here's a short video. It's from the chapter 1 of what they call the natural language processing course. Less of a course than a guide. I haven't seen anything graded or anything like that. And I'll just work through a Jupyter notebook here online, and then have that able to be downloaded for you on GitHub as well. Thanks, and if this is helpful, please do let me know. Thanks. So before we get started, just a reminder, this comes mainly from me working through huggingFace's natural language processing course, chapter 1, and then trying out their examples and trying a few other things as well as downloading certain data sets to try some stuff. Hopefully it'll be easy to follow. If you know something about programming, you should be fine. There's nothing especially complicated in how I call things. And if you don't know about anything much about programming, you'll probably still be okay, although you'll probably just want to watch the video rather than actually work through the entire notebook. So we're going to run the notebook. You'll want to have Python. I use 3.9. You can probably use anything 3 something. I use Anaconda. That's just what I'm used to and what I know. There's other Python options as well. PyEnv, Poetry, pipenv, all sorts of options. So help yourself. If you do use Anaconda, here's how I set this up with TensorFlow, Transformers, PyTorch, Jupyter. Note that some of these can take some time to download. I think TensorFlow and PyTorch might be especially large. Additionally, when we start using the pipeline function, which we'll talk about, it will download pretty big models. These are all ready to go models. I think I have over 20 gigabytes of data in my Anaconda 3 packages. So just keep that in mind. You'll need some space. It is reused between different environments. So if I have multiple Anaconda environments, for instance, as long as it's the same actual models, you should be fine. Finally, there are a couple warnings and errors that come up. The most common of which is the first one here. Using a pipeline without specifying a model name and revision in production is not recommended. Basically, many times when I'm using this, I'm just asking for, give me a model that does this, and it will pick whatever the default model is, whatever version of that is. And that's great for these types of purposes where we're just demonstrating what we can do and showing some stuff off. It's kind of crazy to do in a production environment, or even do between different data sets if you want to compare them. But for this, it's fine. And so that warning makes a lot of sense. So again, all this data comes from mostly huggingFace, except where I put out a few more things and download some data. And any mistakes are my own. With that, let's go ahead and get started. First, I'm going to load a helper function. It's just a very simple timer function I made. I was actually demonstrating it to a colleague of how to encapsulate and write kind of a cleaner function. You don't need to understand any of it except how to use it. So I'm going to load timer from my local file, or JDB timer. I will execute it, and then I'll show you a quick test of what it does. For those who don't know these, I'm instantiating a timer. I'm telling it to start. Time.sleep will just tell the computer or the process to wait, in this case, half a second. It doesn't keep it busy doing anything. It just actually makes it wait a certain period in real time. And then run CPU time is a quick function here where I have it do some silly complex math just to keep the CPU busy. And I check to make sure this is roughly that many seconds. So this is roughly 1.7 seconds. So when I run that, we can see that the first printout, it waited a half second, and I call that wall time in terms of how much time has actually passed, but no CPU time. The CPU wasn't busy doing anything. Then there's been 2.3 seconds of wall time and 1.7 seconds of CPU time. And then there's finally some more wall time, but no CPU time. So what this really is for is we can see how long it takes in, quote, the real world in the left column and how busy the processor is on the right. I'm running a Mac Air, I think it's a 15-inch M2, and so it has multi-cores, so often we'll see high levels of CPU in short periods of time. So with that, let's jump into pipeline and sentiment analysis. So everything here in this example, in this whole notebook, is from the Transformers package, which is put together by Hugging Face. There's a lot of really cool stuff in there, and we just touched on a few parts of it here. We're going to import pipeline, which is a really neat function they put together that makes it super easy just to get started. You can also set up, if you're more familiar with traditional encoder decoder models, you can set up that in the tokenizers. Pipeline just puts it all together in a real simple way. So let me show you that. I'll go ahead and load this. And I'm creating a pipeline with the task sentiment analysis and calling that classifier. It tells me, hey, you didn't specify which one you want, so I gave this one to you, which is fine. I mentioned that earlier. And now I'm going to run, this is a great book and a must read. And it's going to either label it positive or negative and give it a score, which is you can think of as its reliability or its level of confidence and how good it thinks its prediction is. So in this case, that clearly is a positive review. Here's another one. This is not a novel to be read. That's a negative review. In this case, I found these two example reviews on Amazon. The first review was basically, this is on Hitchhiker's Guide to the Galaxy, a book I read a long time ago and really enjoyed. And overall, it seems pretty positive. R2 is the second one. And very clearly, I did not enjoy this book at all. We run classifier with that R1 review. I'll also key up the R2 review. And we'll see the first one's positive and the second one's negative. So these are pretty straightforward examples, but we can see it's getting the sentiment correctly. And again, it's using a transformer architecture for a neural network with an LLM built into it. So with that, now let's try running. There we go. Okay, not sure what happened there. Pardon me. Let's come back to this. Let's try running now by passing this an array. So I'm going to create a list of three reviews. They're a little bit different, as you can see. And I'm just going to call the classifier with those three reviews in one list. And it will give us all three responses. And you can see here that it says, not so sure about a very mediocre book if you like stories about silly stories about talking dragons. But it does feel it's positive if you like stories about talking dragons. And it's pretty confident it's negative if you like dumb stories about talking dragons. You get a sense of what's going on there, right? The words like dumb and silly detract some from what should be what it's putting together. Here I took a quote from Dorothy Parker. This is not a novel to be tossed aside lightly. I'm sorry, it was this quote here. It should be thrown with great force. And here I just took the first part of that, the first sentence, and here I kind of clarified that she didn't like the book in the second sentence, and I can run that. I'm going to send that result to an object called R2, and I'm going to print R2 out so we can look at what's there. So for those who know Python or who know programming language, it's returning an object. In this case, this is a list of dictionaries. Each dictionary has two keys, label and score, and we can see there the first item in the list is for the first message or first string, the second is for the second, and the third is for the third. So that should be a list of three items, three list, and we can print out the labels in R2, which in this case, the label values, the key is positive, positive, and negative. So I built a function. I'll bring it in here. It's a little lengthier than it needs to be, but we can use this function to print this information out in an easier and simpler way to understand. So hopefully it will help those that don't want to get into the gory details. If you don't know, these aren't the droids you're looking for is a famous Star Wars quote that Obi-Wan says to the stormtroopers in the very first movie. I'm going to pass a bunch of these little one or two sentence items to the classifier, store it in R3. Then we're going to run my process function with the messages and the responses. And that's just going to clean up how it's presented. And so we can see, and I think it'll actually sort them from positive to negative sentiment, what the categorizer or classifier thinks of this. So, hey, these are excellent droids. It thinks is positive. I put a plus for positive. These are not the droids you're looking for, but they are excellent droids. Still very positive. These droids are good enough for government purposes, maybe not for enterprise use. Still pretty positive. Excellent droids, but not the ones you're looking for. Then it gets worse. Not what I wanted. These aren't the droids you're looking for. Little inside joke there. These are great droids, but they constantly bicker. And again, all I did was I ran all these and I sorted them by most positive to most negative, and we'll do that a few times so you can get a sense of what's going on. All right, so next I'm going to take in a quote, a set of quotes I have. Oops. All right, I put together a short list of quotes that I find clever. Maybe you'll find them clever as well. I'm going to read them into M4, and here they are. You'll note that this is just printing out the list, so there's the pound, which is typically a comment. I'll want to filter that out, and I probably don't want those new lines in there as well. There's probably 20 or so quotes in there. I'm going to use some list comprehension. If you don't know Python, don't worry about it. But I've been getting into list comprehension. It's pretty fun. And I also tried the filter function. So all that's going to do is just take out the new lines and any commented lines. And now I'm going to run the classifier against that list of messages or all those quotes. And then we're going to do some processing. I'll wait till this is done. We'll know that when the asterisk is complete. And the process will be very quick. The classifier does take a bit longer to run. Next time I'll show you the activity monitor. So here we go. Again, most positive to most negative. Some of these are like philosophical quotes that could be hard for an LLM to really understand and interpret. Some of these are simpler. We should start a club. We should start a team. All very positive. We should start an organization to take over the world. Positive, but less positive. We should start a gang. It's definitely negative. There's a few things here. Some that are requests. Please smoke the ham. It was a dark and stormy night. This is not perfect by any means, but certainly it does quite well. Anyway, there's a whole bunch of things in there that are common, and that's one of my favorite from Albert Camus. We should start a private army is also bad. And I believe as many as 6 impossible things for breakfast. I think that's from Lewis Carroll and Alice in the Looking Glass. So now what I'm going to do is I'm going to load some actual data. I found this data. I wish I'd showed this. I think I just went to Kaggle, Amazon review data, something like that. And I found this data. Oh, 34,000 right there. That seems promising. Let me close the other ones. Yes, I'm pretty sure we used this, and I used it because it had a very open license, but I should attribute it. This is from 34,000 reviews of Kindle, Fire TV, etc. And they probably have a attribution license, not here, but that's okay. I'm giving credit right now. It's on Kaggle, and it's here, consumer reviews of Amazon products. So what I did is I downloaded this, and I unzipped it, and I just loaded it in here. And let me show you what some reviews look like. I'm going to show you 5 of them. This just gets 5 samples and actually prints the reviews.txt field. So there's more here. It just truncates this for a quick example. The full version looks like this. So this is 2 rows worth. And you can see what the ID, the unique ID, the name, the ASIN, the brand, the category. Then you can see some keys. Most important here is the reviews.txt, and we'll also look at the product category, which is called categories here. Each of these is a lot more information. This is the first item, all its information, but again, truncated. So these are all the columns. This is the first row and all the columns in that row. Now, there's 34,000 here, and that's a lot more than we need to look through in this example. So let's do a few things. One is let's get a list of all the categories. So what I'm doing here is I'm saying, get the data frame, take out categories, show me every unique value, and I'll quickly show that to you. There's a bunch. All right, so I'm going to delete that because it kind of clutters up the sheet here, but I can just do that instead. All right, and now we're going to say is I want to group each of these into a temporary data frame called df2 for each individual category and see how many actual records there are for each category. So let's go with that, and this will give us a sense of what categories we might want to include. So for example, computers and tablets, and I truncated it, there's only 4. For Kindle e-readers, there's 6. That's good enough. And I can look in one more detail. Cats 18, which would be the 19th element because they always start at 0. Sorry. Electronics, ebook readers, there are 15, and sure enough, ebook readers, and that's actually the full title there. So what I'm going to say is let's just look at this category. So let's make a new data frame just with that category of stuff. And now I've got 15 rows in there, which I think makes sense because that's what we expected. Yep, we have 15 rows of just that category. So now we just have 15 rows to look at. And I'm going to say, hey, let's take a list of reviews and let's go into that second data frame with the categories with the single category, and let's get all the reviews and let's make them a list and let's just print them out here so we see them. These are the 15 reviews there. So no longer do we have all those extra columns. Now we just see the reviews. And now what we can do is we can actually run this classifier against those 15 reviews. So here I'm going to say start the timer, and then I'm going to send, I guess, to output 5, we'll send it to output classifier reviews, and then we'll tell it to stop so we can time it. And then while that's running, I'll queue up the process function where it'll show us line by line sentiment, most positive to most negative, and we'll see how it does. I'll pause the video here until it catches up. All right, that was pretty quick. The warning, I'll need to update that, but it should be fine. The wall time it took was about 14 seconds, so think of that as real time. CPU time took 83 seconds. Because I have a multi-core CPU in this M2 Mac Air, it can run multiple CPUs at once. So it's not time travel or anything. It's just running 83 seconds of CPU time. And right away, we can see the most positive reviews up here at the top. As promised, thank you very much. Works great as I expected. Then there's some mediocre review, one of fab chargers. Probably not a lot there to really make a lot of sense. Here's someone talking about, really, you should get this, but I think they already should give it to you. More so in the next one, that's where these are negative. Again, this isn't magic. It actually is going through the network and trying to figure out what these are. I'm seeing a common sentiment in having to buy this charger separately. And then, yeah, here's I paid 20 for this slow charger. So that's sentiment analysis. Now let's jump into zero-shot classification. So zero-shot classification is the concept of classifying, or really just generically answering a question, or in this case, classifying a section of words according to multiple categories. And with zero-shot, it means you didn't get any examples to start with. So what's also very common is one-shot and two-shot and multi-shot. So if you're using an LLM and you're in interactive mode, you might say, hi, please take a paragraph and then tell me whether it's about education, politics, or business. And if you just give it a paragraph, then that's zero shot. But if you've given an example paragraph and then give it the answer you expect, and then say, now here's a paragraph I want you to categorize, that would be one shot, and so forth to end shot. So this is a model that is going to do zero shot, which means it's an actual LLM. In this case, it's a BART large model. And I believe it has been tweaked or fine-tuned for zero shot, but that's just generic zero shot. We're not necessarily, hasn't necessarily been trained for our data. All right, so this comes right from the examples. This is a course about the Transformers library. Note, in this case, I pass in candidate labels. So it's actually doing two things here. One is it's taking an arbitrary list of labels, and then it's figuring out which of those labels most likely apply. And these will generally sum to 1. So 84% chance education, chance isn't the right term, level of confidence is better, 11% business, and 4% politics. And generally, these can be words or tokens, whatever. I'm going to do another one, exactly the same, and we should see exactly the same result. So here there's no randomness, if you will. It's always going to find what I think the actual answer is. So while that's going, okay, we'll see the same result. Now I'm going to send in 3. I'm going to send in the quick brown fox jumped over the lazy dog, man bites dog, film at 11, and tobacco shown addictive. Really should say nicotine shown addictive. That was the famous headline. And the candidate labels for all these will be education, politics, and business. So all I'm doing is I have a list of these three strings, and I'm passing it to classifier with these labels, I'm going to get the result. And I'm going to print out the result here. Let me go back. So first I'm printing out the actual scores. And then what I'll do is once that's done, I'll actually print out the object R, which is the result. Okay, lots of warnings and things. So this is just, I'm not passing it in quite the right way. So I'll actually probably clean this up a little bit in the next one. So let's see how we can do that. Taking a look at this, let me skip this part and come back to it. I wrote a function called classify. It's not especially complex. You don't really understand it here. But what it'll do is it'll look through if you send it a list of things, it'll look through that and one by one call classifier so we don't get these multiple warnings. And now let's start with this one again. So let me take this one down here. Okay, so now I'm going to call classify. And then while that's running, let's set up a few more quick things. I want to look at the actual object that we get back. The dots in there, I'm just giving a bit of a status update. I think it's set to roughly 10%, but there's only 3 or 4 items here, so it won't be that long. Again, ignore the warnings there. Sorry, I shouldn't have had those. And here we get the R response, and we see that, okay, it gave us 63% for the quick brown fox, and 45% business, sorry, 63% business for the quick brown fox, 45% business for man bites dog, and again, business of 54% for nicotine. Okay, and just to show, these generally add up to 100, I'll take the examples up here and I'll move them down here. So this will be right in the download you were welcome to get on my website and on GitHub. And these will be not quite 100% or just 1, probably because of rounding, etc. Close enough, we feel pretty good about that. So the idea is that between the 3 categories, it thinks it's got full coverage. It's one of these. Now, what's really interesting here is if I set up different categories or add a category, just add one category, the results will change. So let's do the same thing, but this time there's a 4th category. It looks like I'm added, actually no, sorry, that was business, politics, education. This is education, news, politics, and media. So this will be entirely different. Again, I'm gonna get I won't get the warnings, so I think I called the classify function this time. Yeah, good. And it's going to return the object, and the object should just print out automatically. So we'll give that a few seconds. Okay, here we go. And we can see the responses 53% for news and media, 83% for news. And last time it was business, but there's no business category here, and there's no news category earlier. So let's try another interesting example. We're going to take man bites dog and surprise ice cream heist. I leave that to your imagination. And I'm going to set up multiple lists of different categories. These 3 are separate lists of categories. This is the same list as above, but in a different order. And there's a much longer list. So basically I'm saying take this sentence and then categorize it or do the 0-shot classification based on this, and then based on this, and then based on that, etc., etc. And hopefully I set this up right. And I'll take a pause here. Here we go. Here are the responses. For the first one, again, these are all the same sentence. Man bites dog and surprise ice cream heist. It thinks, well, news is a very likely right categorization. It still thinks that the second time when I add education as a category. This time it says, well, when you don't have education, you do have news, but you have animals. I think it's 69% likely to be animals, 31% news. Again, rounding. Then if I have animals, news, sports, and politics, this is exactly the same. I just put it in a different order to show that there's no difference. So essentially what happens is it runs through the model each time with that label, and then it scores that label. And here I have a whole bunch of categories, including violence, which popped up right away. One thing to keep in mind is that the more labels you use, the more essentially scattered, more distributed the responses will be. Even if you use the same number of labels, changing labels can be very problematic. So when you're comparing different items for what categories they are, you would almost always use a standard set of labels over and over again, and be very wary of ever changing them, because you want to make sure that you're comparing apples to apples, if you will. Let's take one more set of data. This one I picked off of, I also Googled for data, and I found this on Kaggle. This is from Rashaba Misra. It is some article data. I think it's from Huffington Post. And let's see this. We have 42 news categories, and we have the article name and the description. And there's several thousand in there. We'll talk about this. This is referencing where it came from. Thank you. I'm going to, again, load this in pandas. I'm going to load the file. Yes, and I remember working through this now, but let me show you how I did. There was a JSON decoding error. If you don't know JSON, that's okay. It's just a way to store and handle data. I looked at this, and I found pretty quickly when I went to discussion that this was found by other people as well. The JSON doesn't work. That was my problem. And someone explained, I forget what it was. Thank you, Scott Bradley. JSON file is technically one file. This is multiple JSON files, one on each line. It's technically called JSON-L, which I didn't know. All that means I have to read it in slightly differently. I need to read it in line by line. So that's what I'll do. So rather than reading the whole file in once as one file, because it's not one logical file, I'm just going to set up a list called data. I'm going to read in a line by line, and each of these will tend to be a file in data, which will look like a regular line. There we go. Now I've got 209,000 rows. I'm going to load this into the pandas data frame again, and let's look at the first few. Head shows us the first 5. These are all the columns. We see a link, a headline, category, short description, authors, and date. Now what I want to do here is I want to take some of these and then see if we can figure out the categories for them. But I think a more interesting test would be to actually choose categories that this data set thinks are there as well. So let me explain that a little bit better. I don't just want to pick 5 random categories and then say that looks right or wrong. I want to say, hey, let's pick X number of articles from this data set, and then let's randomize the list of categories and see if it can figure out which categories belong to what. So in this case, there are 42 different categories in here. I'm going to find out how many there are for each category by simply going through, making a small data frame for each one. That's actually not true. I'm not making a data frame. For each item in data. So for each row, I'm going to look at, all right, to explain this a little more clearly, what I'm doing is I'm looking at the list, not the data frame right now, looking through each row in the list and looking for the category, and then shoving that into a dictionary, either incrementing 1 if the category name is already there, or setting it to 1 if it's already there. And from this, I can tell how many items are in each category. The way I would look at that is I would just print out the dictionary. Oops. Oh, a little lag there. And I can see each one there. Okay. So college has 1,144. What I'm going to do is just pick a few. I'm going to pick world news, tech, sports, education, crime, and parents. And now I'm going to say is that old data frame that I have, which has, I think, 209,000 rows. I'm going to say make a new data frame that only includes rows that are one of these categories. Okay? So that's the new data frame 2. I'm going to print out the unique categories in data frame 2. Oh, I didn't run cats here, I think. There we go. So when cats was empty, it didn't find anything. But here I assigned cats this list and said, okay, yep, now there's a new data frame. Let's take a look at it. It's only 19,000. Okay, so that's substantially less than the 209,000 we had before. And we can look at a couple. Actually, let's do this. I'm going to take a random sample of 10 out of that 19,000 and call that DF3. And let's take a look at DF3 now. And what we have here is 10 headlines, 10 short descriptions, and 10 categories. And by the way, if I repeat this, I'll get different results. And in this case, because there's no short description there, that won't quite work with some of the logic below. So let me just run that again. And this looks fine. Nothing's blank. Now what I've got here is going to say, give me all the headlines. So that headlines are all the this column right here. Also give me all the short descriptions. That's there. And then make a combined version. There's an easier way to do this, but I forgot what it was. So I just make a combined version of headlines, colon, description. So now I've got these 3 different groups, and I'm going to do classification on all of them. So let me walk through this. The first is going to say, hey, classify just based on the headlines with those possible labels. So it's going to look at just the headlines column and try to figure out, 12 lessons from pre-internet days parents wish. And it's going to try to figure out whether that's sports or tech or parents or one of the other ones, crime. Then I'm going to just pass it the description and have it do the same thing. And I'm going to pass the combined, which is the headline with a colon and the description. And I'm going to set A equal to the entire list of categories that are there. These are actually like the answers, if you will, in order. I didn't run this part yet. My apologies. There we go. This took a little bit of time to run. And here, it's just a little bit cleaning up to make it much easier to read. We're going to print out the headline and description for each one, the original classification, which is the answer, if you will, which isn't always right, but it usually is. And then what it thinks are the right categories for the headline analysis, just the description analysis, or the combined analysis. And then, okay, so it's still running here, and I should show Python is running at a high rate when it gets updated. So 452% CPU because of the multi-cores. And once that's done, this will drop back down. Maybe I should have put a timer in there, but no worries. I'll pause till we catch up. I'm unpausing just to show the first one finished. We have 2 more to go, and that took over 1.5 minutes and much more CPU time. So I'll pause till all 3 are done now. We're all done. And now I'm going to run a function that just kind of prints this out for us more clearly. So here we go. The headline, Mac OS old school skin will take your laptop back to 1984. The description is, are you a Mac user who wants the power and speed of modern day laptop, but yearns for the best graphics and stripped down, and it truncates there. It looks like based on the headline alone, it thinks very likely tech. And then parents, interesting, maybe the back to part is part of that, or school. When it looks at just the description, it thinks tech and then maybe sports. I wonder if speed might be part of that. And then when it does both, looks at likely to be tech. And the actual answer is tech, at least the answer according to the original one. So that's a good one. Let's see if we can find some more interesting ones. This one's crime. This one's parent. This one I got wrong, so let's take a look at this. Toddler who lost eye to cancer. Wow, I'm sorry that's not a great random response, but toddler who lost eye to cancer formed special bond with toy that looks like her. And it was called Parents, which I could understand, but it's also pretty understandable that tech would be high on the list, as bonding with a toy does sound like something which would be certainly possibly technical in nature. World news I don't quite see as much of, but so be it. Let's look for some hopefully happier headlines down here. Here we go. Hackers made 100 million with info from stolen press releases, FBI. Now they call this tech. Just based on the headline, I think crime is probably the right response, the right categorization. But when you read the description of, hey, the lesson is that your information is only as secure as the people you share it with, I certainly can see why tech becomes more likely. So it certainly is arguable either way. And then here we've got a couple more to go through. Sports, tech, those are pretty straightforward. Parents, then we've got education, and interesting. 11 life lessons I learned from my grandfather. I think the grandfather part clearly calls out parents. I'm guessing lessons and learned helps it lead into education. I'm not sure about the tech part of that. Not sure at all about that. All right, so anyway, this is just an example of how to do this type of thing. There's nothing magical about these 10 examples. They're randomly picked from, I think it was 30-some thousand. I just wanted to show as an example that you can take some real data and you can run against this. There's also the possibility that this data was used in training of this model. If that's the case, you wouldn't want to use this data. Generally, that's not an issue because you'll be using new data with any pre-trained model. But certainly when you actually do your testing of any kind of LLM, you want to make sure that you're using data for a holdout test set that it hasn't been trained on, or the results will be artificially high because it was very much trained on that data, so it should work well in the first place. All right, next let's talk about text generation, again from the examples online. I should clarify, the examples online didn't go into nearly as much detail. They didn't talk about public data sets. I just added that because I thought it was really interesting and wanted to share. And we're doing a text generation pipeline, and I'm just showing the timer again. And today we will see, and it's going to generate the next few words. And that was really boring because it literally just predicted the exact same thing. So it basically predicted an end of sequence response. If I run it again, we'll probably get something different. And I can tell it's going to be different because it's longer. And every time it has to generate a new word, it runs through all the words again and keeps doing that. So it actually will take more CPU time. Not that I'm recording that here, but we'll probably see a longer sequence. I'll pause till we're ready. There we go. And here we see, today we will see that the government is taking significant steps to address the threat. And it keeps going. So now what we're going to do is I'm going to use the timer. This is just a warning that I didn't set the pad token ID. So I'll just set it here. So now we can actually see these and see how long they take. Maybe I'll do a couple more since we were looking at how long they might take. I'll queue that one up, and I'll queue that one up. All right, I'll pause this. Interesting. So this one generated today, we will see why, and then a new line, and then it's an event I've been asking myself many times this month. And this was took quite a bit of time, actually. This one, I think, is the same number of words, probably tokens, but was certainly quite a bit faster. Looking down, again, very different responses, quite took some time. Really hard to tell, what's going on. But remember, it's calculating word by word. So afterwards, he sat in, it's a very likely word is the coming next there. And then the might be center or room or all sorts of things. One thing I should share is when we were doing classification or categorization, these things were determinate, where if you gave it the same string in the same categories, you'd always get the same result. Here, there's a level of randomness, or a ChatGPT world, we call that temperature, where it's actually choosing words probabilistically, which makes a lot of sense for LLMs in most scenarios because you don't want to just generate the same thing every time. And there's lots of ways to control that. One of the most popular is to control the temperature so that words come back with probabilities. And if you want to have a high degree of creativity, you could flatten that curve, if you will. So rather than, the first 4 words being a 50% chance of occurring, maybe they're only 20% chance, and there are a whole lot more words that show up with like more than 1% chance. So here we'll pass in a list. In this course, we will teach you how to get elephants to stop. And then in this course, we'll teach you how to get elephants to. I'm going to just pass in both, and we're going to print that out. I also put together a quick function, not really the best method, to be honest, but it'll work, which kind of cleans up the output so we can read it a little bit better. So while that's running, I'm going to do the same thing. We have P is the list of these 2 sentences. We'll get those 2. And here I'm going to send it asking for 2 sequences for each one with at least 100 length. Let's put 150 there. And then I'll ask for 5 for each with a minimum length of 10 and a max length of 20. And in this case, it's words. I think in other cases, it's often tokens. Again, you can have more than 1 token per word. And that gets into the parsing and the encoding. And we'll probably talk about that at a later date. Okay, just realized I made a mistake. Oh, I think I just didn't execute the genprint function here. Yeah, there we go. Let's try that again. But the first one should be done, so let's peek up here. So here we go. The first generated text is in this course. We'll teach you how to get elephants to stop killing themselves in the wild. Wow, this got dark. The second response is to get elephants to stop, period. Take care of them when they're scared. And then after the stop, there's 2 responses. We'll teach you how to get elephants to play outside their natural habitat. And teach you how to get elephants to respond to music. Okay, that's intriguing. Again, depending upon the model and the complexity and the prompt, these might be really coherent, sensible things to respond with, or they might kind of sound like gibberish. It really depends on what you're getting. Those are still working. I remember taking one of the TensorFlow courses at deeplearning.ai. Lawrence Moroney. What he did, which is pretty neat, is he took a poem, I think it was in Gaelic, the written language in Ireland, and he gave it some training words. This wasn't an LLM, it was just a straight up machine learning algorithm. And then it generated other words that could come from that in a similar sequence model. And that more just sounded almost like gibberish, even to someone who spoke Gaelic, but it reminds me of that quite a bit. So anyway, let's go back. That was a great set of courses, by the way, on that certificate. Jumping back to this, here we go. We can see the response. So here, this call took 700 CPU seconds, and that's because it gave us 2 responses for each of the 2 sentences. Interesting, this one gave its bullets this time. That's kind of neat. Elephants to stop playing with dolls for the first time. Okay. But these are longer. And I actually put a word count in there as well. So this is 90 words, 131 words. Definitely longer completions. In this case, this went much faster. We actually increased by 150% the number of responses, but they were much shorter. And because the way these models work, they weren't iteratively to generate the next word each time. So this course will teach you how to get elephants to stop using drugs. That's good. How to get them to the African forest at night and to behave as they want. All right, next we're going to cover mask filtering. Mask filtering is the concept of taking a full sentence in a language such as English, and then taking one of the words in that sentence, masking it out, possibly adding 1 or more additional words that go right after that word. So you might mask out a single word or 3 words in a row. And then what the job of the LLM is to fill in what goes into that mask, or what are the missing words with the level of confidence that it has. One of the reasons this is really important is a lot of LLMs are trained this way, in terms of just taking huge corpuses of text and then getting these random sentences from these corpuses, getting the mask, trying their answer, and then when they see the actual answer, doing the back propagation in a way that it kind of tweaks the weights of the matrix toward getting that answer next time. So let's jump through. As before, we're just going to call pipeline again, and it warns us that we haven't specified an actual model. Okay. Never forget that mask is the most important rule. Here we get simplicity, patience, consistency, humility, and moderation. Okay, those are all pretty reasonable. It gave me 5 by default. Note that. This time, let me get just 3, and that's going to run pretty quickly. And this is deterministic. We got the same one, simplicity at 6.93%, and then we get patience, and then we get consistency. What I'm going to do now is write a quick function. I already wrote it actually, which will just present this in kind of a slightly easier way to read. So I'll do that here, and now we'll get the top 15, and I'll run the top 45 as well. What I'm doing here is I'm putting out the word, the token number, which only matters if you're doing some of the decode yourself. The probability you see goes down. The aggregate probability is the probability that it's this word or the word above, if you will. Remember the confidence level. So getting to the top 15, we get to almost 40 or 40%. And going to the top 45, we get to about 57%. It's an interesting way in terms of how they give you the possible words. I had some fun with this. On rainy days, never blank to bring an umbrella. Forget, remember, hesitate. I like how forget and remember are the top 2, but clearly forget is 86%. So it's very much high on the list. Everyone in Spain loves It's a national treasure. Catalonia, I get. It, okay, chocolate wine. Pepe, maybe Pepe, other than being a very common name. Maybe it means someone in particular. One mask to rule them all for Lord of the Rings fans. And we did not get ring in that. I almost want to like put in a 40 there and see if I can get to ring. But I don't think I can. So what a bummer. If someone sees ring in there, let me know. But I'm pretty sure it's not there. Okay. Little Groucho Marx line. It won't belong to any the actual code. I think it's club that would have me as a member. This does pretty well. Note the American spelling of organization, then the English or a British spelling. Club, group, party, all makes sense. And then I had this twice. I think I only need it once. My top 10 list always includes a mask. Oh, and I spelled it wrong. That's why. At least that one person, one famous person, and then I have at least one famous person. And they are a little bit different because the math is a little bit different. But, you know, the second number here is comedian. The second number here is celebrity. So be it. All right, named entity recognition. This one I actually wanted to do more with because I didn't get great results with it, but I'll just show what I have here. In this case, I'm setting grouped entities to true. What that does is it allows two words that appear together to be seen as one entity. So we'll just show that. I took a Hugging Face example, except I think I made up Pablo, so I forget the actual name. But it'll do a pretty good job of recognizing, here we come down here, Pablo and Hugging Face, and I think Brooklyn. So look at that. Person, Pablo, the organization, Hugging Face, and Brooklyn is the location. Very good. I'm going to write a helper function just to kind of clean it up a little bit. Here I took I think this is from it's either Wikipedia or the biography of Abraham Lincoln on whitehouse.gov. I print out what it is so you can actually see the whole text. There's quite a bit of content here. And it's going to try to figure out what means what there. Abe Lincoln is a person. I think it's a grouped entity. American, United States is the location. American is a MISC. It's doing okay. American Civil War is the miscellaneous. Confederacy is an org. Clearly, you know, we could argue nits, but certainly it's doing a pretty neat job of trying to figure out what's going on. Penelope drove to Madison to see the Packers. I think it'll recognize Penelope in Madison, but not Packers. Madison is the capital of Wisconsin, a state in the U.S., and Packers are an American football team. If I capitalize the P, in this case, I think it'll show up just fine. The capitalization is definitely part of that. Let's see what we do with smorges. I'm not even sure why I put that there. I wonder if that's a typo. Oh, interesting. So what's happening here is it's breaking up one word into 3 tokens, and it's trying to guess MOR as a token and GES as a token. I just picked that as kind of a nonsense word. If I make it a slightly less nonsense word and say stooges, it does a little better, I believe. Okay. And if I lowercase that, I think it still recognizes it, but it's less likely. Nope, doesn't recognize it at all. So it was miscellaneous at 43%, and now it's, nope, don't even see stooges. I did some of these with soccer from Wikipedia definitions and simple Wikipedia definitions. It really did not work well. I got a lot of, sorry, Anne, I don't know what you're thinking of. Actually, nothing. So I tried some like Dick and Jane-like language. Here's my cat sat on the bed, my cat is white. And nothing worked there, which was surprising. I think if I kept it simpler, though, it did a little better. No, I also did badly. Let's try this. The cat sat on the hat. Okay, let's try to find at least one that works. Okay, I eventually settled for Joey ran after Paulo, where at least I could get 2 people to show up there. Again, this is just the standard default model. I haven't tweaked any settings, haven't tried to find the best model. So really not super great in these responses. We'll do a few more. Here we get Jane and Bob show up. There we go. We get Jane, Bob, George, and Al. And I took a Martin Luther King quote. Not a quote, sorry. A quick biography. I think this is from Wikipedia or Simple Wikipedia. And I'll print these out again. Here it did okay. Oh, I didn't actually print M. I just, and the same thing here. That was the response. But it does a pretty good job of putting together what is what. And it looks like this is the longer version of this. I'm going to clean it up a little bit, but basically the same responses. Okay, let's take a quick look at question answering. This one I found was a lot more fun to explore in the ChatGPT examples, but we'll cover that later. And again, I'm just scratching the surface of what we can do. But in question answering, we set up a pipeline and we pass it a question and we pass it context. So I think this example comes right from huggingFace. I think there is a Sylvan at huggingFace. Hi, Sylvan. And it will recognize that, hey, when you ask where do I work, and this is your context, it says huggingFace. I try to get a little more clever with it. What city do I work? Ideally, it would say Madison, but grammatically, it's still right. I'm trying to figure out if it goes out and gets any information. I don't think so. I believe the 42nd president is Bill Clinton. Alexa, who's the 42nd president of the United States?
William Jefferson Clinton was
That's
the
him.
42nd president
Okay.
of the United States, serving from 1993 to 2001.
Thank you, Alexa. I did some simple equations. For the most part, it did pretty badly on these. It could kind of keep track of that was kind of interesting. Note that a lot of more advanced models will actually be a combination of models. So they'll figure out like, oh, you're asking me to do some math, or oh, you're asking me to set up a series of stages or directions or whatever. So this is just using a straight up question answering model, which probably isn't very flexible. So certainly you could combine models to do more interesting things. But I still thought it was kind of neat. And the end results, what is value of x plus y? What is value of y plus x? It really wants it to be 3. Okay, so be it. And then one or two more. We'll do a summarization. Here I took a famous Hamlet quote, to be or not to be. I changed a few of the words just to be a little clearer. We're going to have a summarization pipeline, and I'm going to call the summarizer on this. It's going to read the whole thing and then process it and then give us a response. Then I'm going to run it 2 more times with min and max lengths. And let's pause until it's ready. But I would just show that the Python process is quite busy. Because again, this is all running locally, right? We're just instantiating this and we're running it locally on this Mac and the M2. The first response is in. To die, to sleep, that is the question. 'Tis nobler in the mind to suffer. I think it should be like, oh, I see, it's just summarizing, of course. There's the second one. And similar, but not the same. Third one should be here shortly. Again, that's a lot of text, and it's Shakespeare, and it's super famous, complex Shakespeare, so maybe it shouldn't be doing that great. While that third one's coming up, here I took an Abraham Lincoln bio from the White House. We'll go ahead and put that in there. Maybe I'll print that out so you can see it as well, and that won't happen until that summarizer call is complete. And then what I'll do is I'll call the summarizer, how about with the length of 40, and then maybe 100, and then let's do 180. Okay, so there we go, and we're ready to go here. Let's run these 3, queue them up. Oh, my mistake, have to be at least 60. Okay, all 3 responses are in. The 60 max length, there it is, and it looks like it actually uses that, plus it, for the 100 words, it actually adds this as well, and for a max of 180, it appears to be exactly the same. It isn't always like that. Sometimes it'll reverse a sentence or include another sentence earlier on, but it's you can see it's somewhat deterministic in what it's trying to choose. Next, let's look at language. This example I took right from huggingFace because I do not speak Hindu or Arabic, and I barely speak English, and technically I learned French a long time ago. There's no actual pipeline function for this that I could find. So here we have to set up the model and the tokenizer and then run these directly. This is very common if you're used to running these in the way that they were originally set up. Pipeline is just a very convenient way to do this more easily. But here we go. We're loading in these functions, these methods from transformers. We have the languages here, and we're going to run a model and tokenizer. We'll run them here first. We'll take the Hindi and turn it into French. So we'll encode it with the tokenizer as Hindi, and then we'll decode it essentially, or generate it as French. We'll see what that looks like. And here we'll do an Arabic to English. We'll just queue that up. So my French from years ago, I think it's the chief of the UN. There is not a military solution in Syria, as if that says. Let's look at the English translation. The Secretary General of the UN says there's no military solution in Syria. That, of course, is doing the other language. Now I thought we could be a little bit goofy. Let's take the English phrase, time flies like an arrow, fruit flies like a banana. That second sentence is meant to be ambiguous. Is it fruit flies like a plane flies, fruit flies like a banana, or is it fruit flies, the noun, that there are fruit flies? So that's a fun one. I'm going to go ahead and set that up, and then I'm going to set up the tokenizer and put it in M2. Then I'm going to put in the strings put together in M3. Then I'm going to run this to finally wind up with M4. And in the end, when it's all done, we're going to see the original, what it looks like encoded in French, and then back to English, and we'll see how it does. This is a very common way of testing translation programs, is to translate a sentence or phrase into one language and then translate it back. And for those who speak more than one language, often know that that can be very hard, especially if you're using idioms or using terms that are quite ambiguous in nature. Many times when you translate from one language to another, you're making a judgment call about what someone meant or what they're referring to, and that's lost information in terms of they may have meant something else. So let's see what we got. Time flies like an arrow. Fruit flies like a banana. Okay. Time goes like an arrow. And then fruits like bananas. All right. The first one, I think for sure. The second one, not quite sure how it got fruit, but so be it. Last thing I want to show just really quickly, and Hugging Face does a great job just talking about this briefly in the chapter 1 intro. While there's no like bias programmed into these things, LLMs are trained on usually all the data that's out there. And even when attempts are made to only train them on good data and weed out the bad data, a lot of things still stick around. Sometimes it's because of stereotypes, maybe stereotypes that were true historically but aren't true anymore, or maybe just common falsehoods, like a stereotype of almost all teachers are women. In America, 100 years ago, that was probably true because that was one of the very few jobs open to American women. And then you might have heard, I heard when I was a kid, that blood without oxygen is blue. That's not true, but it was a common misconception. So there are certain things that I might get trained on that are harder to pull out. There's a lot of work being done by Anthropic and a few other companies around the 3 H's, making sure LLMs respond with responses that are helpful, that are not harmful or harmless, and that are honest. And that gets into, I'll talk about this later, but the hallucinations and things where it's just making stuff up isn't very helpful. So showing that, we'll set up this model. The man works as a, and what might we see there? Carpenter, lawyer, farmer, businessman, doctor. Those all sound fine. The woman works as a nurse, maid, teacher, waitress. I mean, a little sexist. The woman could be all these things as well. Maybe not a businessman, maybe a businesswoman. And then, if I recall, a prostitute, which is, I'm certainly not the fifth most likely career for a woman. So that's disturbing. I did a few more examples just to kind of show how you could wind up with different things. The doctor married Mask in a large wedding, married her, assuming the doctor's a guy, married Anna. I wonder why Anna shows up with a 15, or that's 1.5%. Okay, so it's very likely her, and then it's a very long tail. And then I chose the doctor was from blank in Africa, and it chose Kenya and Uganda and Tanzania is very likely, although some were also counted. And then I tried to really set it up to see what it would say. And again, it's trained on just all these sentences in text and corpuses or corpi that have homelessness and mental illness and things mentioned. But hey, what are the 2 largest causes of homelessness? They're blank and mental illness. Poverty? Okay. Unemployment? Sure. Tuberculosis? I probably not. Hunger, I don't think causes homelessness. And the last one there, alcoholism, I could certainly see, or any kind of drug abuse. Right, so that's my quick summary in an hour or so of what I learned from my first walkthrough with the Hugging Face Chapter 1 of the NLP course. I hope you found it helpful and interesting. Please let me know. And I will do one of these for ChatGPT soon. And I may do more if there's sufficient interest. Thanks for watching, and you can download this Jupyter Notebook on my website. Thanks.